Welcome to Robotics 101. This is Robert with SparkFun Electronics, and today we're going to be talking about transfer of motion. Transfer of motion is a core concept in robotics, and it's any time you need to transfer motion from the motor over to the output shaft, the wheel, the lever, whatever it is, without a direct connection. In the previous video, we talked about the concepts of angular misalignment and also parallel offset. Angular misalignment is when you have two shafts that are angularly misaligned to one another. Parallel offset is when the two shafts are parallel to each other, but there is a slight offset in some plane. The first one, angular misalignment, is pretty easily remedied by different shaft couplers like a helical coupler or something like that. The parallel offset is a lot harder to fix. However, with transfer of motion, we can use belts, pulleys, chains, sprockets, or even gears to fix both of these issues. A gear is a rotating machine part that has teeth or cogs that mate with other gears to create transfer of motion. For this video, we will be talking about spur gears and pinion gears. A spur gear is what most people think of as a typical gear. It can be just about any size, have many or few teeth, and be made of just about any material. So a pinion gear is very similar to a spur gear, and they look almost the same. The difference is the term pinion is used to describe the smallest gear in a gear set, or usually the drive gear. The next thing you need to know about gears is the tooth pitch. The pitch is the distance in between the teeth or the cogs, and this will tell you what gears this will mate up with. So if this has the same pitch as this gear, they will mate up perfectly fine. If they have a different pitch, they will not work together.
Gear ratios are used for two major things: slowing down or speeding up an output, or increasing or decreasing an output torque. As you see, there are two gears in most gearing systems, and you have typically an input and an output stage. In this case, we're using the input stage from the motor and the output stage to our wheel or whatever we want to turn. 4 turns of the input equal 1 turn of the output. There's a number of ways to find that. You can look at counting teeth on either side. So if there are 40 teeth on this gear and 10 teeth on this gear, you still maintain a 4-to-1 ratio. Another way is if this gear were 1 centimeter and this gear were 4 centimeters, you also have that same relationship. Another application for gearing is torque multiplication. Take this textbook, for instance. If I hold the textbook close to me, it's very easy. I can hold it for a long time. If I take the textbook and hold it away from me, it takes more effort and energy to maintain stability. So the same principle can be shown right here. Foot-pounds of torque are used in automobiles and motor performance calculations. What is a foot-pound of torque? If we take 1 foot of length and hang 1 pound from it, we have 1 foot-pound of torque. If we have 4 feet and 1 pound, we have 4 foot-pounds of torque. To bring this back into how it would work with a gear ratio, we have the input torque of a motor as 1 foot-pound. As it acts on the second gear, we get this torque amplification factor of 4. So while we're slowing the motor down 4 times, we're increasing the torque by 4 times, giving us this 4-to-1 ratio.
So gears can be very useful when the motor is relatively close to the output drive shaft, because they have to be relatively close to one another. That is one of the pros for using gears. However, because you have a solid contact point between the two, they're very robust, very reliable, and not very prone to breakage, unlike a belt or a chain which could snap or come off. Gears are very useful when you have a motor that is very close to the output drive shaft. Because there is a physical limitation of how close these need to be, that is one of the downsides to using gears, is they actually need to be precisely aligned next to each other to be useful. One of the benefits of using gears is because it is a physical mating between the two, you don't have a chain, you don't have a belt, the power transmission is very good and they're very robust and very reliable. You don't have to worry about a chain or a belt slipping off or breaking. Chains and sprockets are another way to transfer motion. Like gears, they have teeth or cogs around the outside of the sprocket, but the main difference is these teeth are made to mate up with a chain as opposed to a gear that mates up with another gear. Whereas a gear is ultimately defined by the tooth pitch, a sprocket is defined by the size of the chain that it utilizes. The main advantage of a chain and sprocket system versus that of a gear system is the gears need to be right next to each other and they need to be precisely aligned, Whereas with a sprocket and chain setup, you can make the chain as long as you need it to be, and it can be aligned pretty much anywhere you need. So you have a lot more flexibility in where you mount both the motor and the output shaft. The other nice thing about using a sprocket and chain system is you can always break open a link in the chain and add another one or take some out to make exactly the size chain that you need. The last method that we're going to talk about are pulleys. Pulleys are very similar to sprockets, except for they don't have any teeth and rather rely on this smooth channel and rubber belts to transfer the motion. One of the disadvantages to using a pulley over a chain is because there aren't any teeth, you can get a lot of slippage and there is some flexibility in the actual belt itself. So you see there's a bit of flex in this. Another main difference between a pulley and a sprocket is of course the lack of teeth, and that means that the power transfer is going to be a little bit different. A chain is not going to have a lot of slack and not a lot of give. I mean, it's going to be negligible. However, with a rubber belt such as this, it's going to have a lot of slack and a lot of give. Now, for certain applications, that actually might be desirable, but ultimately what that means is a belt like this is not going to have quite as much power transfer to it, and it's not going to be as good for higher torque applications. The last thing I'd like to mention about belts and pulleys that is completely unique to them is the ability to transfer power at a 90-degree angle. Unlike a chain, you can actually transfer power like this. So if you need to transfer power at a 90-degree or perpendicular, a belt and pulley is a perfect solution for that.
So timing belts are a happy medium between chains, flat belts, and gears. The advantages of a timing belt are you have these teeth, much like a gear. Timing belts are also wound with a Kevlar band most of the time these days, and that gives you the same inflexibility as a chain. Timing belts really lend themselves to things like timing. They were originally invented for automobiles to replace timing chains, which are critical in keeping the engine in sync. Timing belts offer a great solution for other timing applications or precise motion, such as printers, laser cutters, 3D printers, all kinds of applications.
Oftentimes when sourcing components for your project, it's difficult to find pieces that all work together. The thing we like about the Actobotics product line is all the gears have the same pitch, the belts have the same belt size, and all the sprockets use the same chain. The other thing that can be kind of problematic about using gears is knowing the spacing between the gears. Because Actobotics uses a standard spacing, you know that the gears are all going to line up. They also have a lot of products like the channel gearbox, where the gear mating is already done for you and you can just select the gear ratio that you want. They also have a full line of pinion gears that go into servos to mate with the rest of the gear system. And all of these use their standard 0.77 or 1.5 inch hole pattern, so all you have to do is connect a hub, connect either a shaft clamp or whatever other mount you want, and it all works together. So hopefully this gives you a lot better idea of how transfer of motion can be achieved through belts, gears, pulleys, sprockets, chains, and everything else. Please join us next week where we're going to be talking about precision motion.